Welcome to Algebra. Algebra, in essence, is the study of equations involving unknown numbers, or variables. Throughout our study, we'll find many ways in which we encounter these unknowns and how to solve for them. When we were working through our study of prerequisites for algebra, we never solved anything. We only simplified. That's because in order to solve something, we must have an equation. What is an equation? Well, for starters, we say it's something that's equal. If a statement has an equal sign in it, such as 5x plus 3 equals 13, we say that it's an equation. Equations are how we define things mathematically. Maybe you remember back when we studied polynomials, we talked about the discriminant, the square root of b squared minus 4ac. This told us whether a degree 2 polynomial has a special factor or not. This expression is not an equation because it's never defined to equal anything. It's just simply a tool that's used in the theorem. Before talking more about what to do with equations, let's introduce the most basic and common type of equation, the linear equation. Definition of the linear equation. An equation is called linear if it can be written as a polynomial of degree 1 in the form ax plus b equals 0, where a and b are real numbers and a does not equal 0. Let's start with the left side, ax plus b. X here is called the variable. While we already looked at variables a bit previously, we never got around to talking about what they really are. A variable is an unknown number. We know that it's some real number, but we don't know what it is. It can vary. That's why we call it variables. Now look at a and b. Those are the real numbers. We know what those numbers are. If we're looking at a real linear equation, you won't actually see an a and a b. You'll see some real number. A and b here are used as placeholders. The a is our coefficient and b is our constant. In the definition, it's stated that for our equation to be linear, it cannot equal 0. Think about it. We wouldn't have an x term if a equals 0. It's fine if b equals 0, however. Now look at the right side of this equation. We've set this equation to equal 0. In a future chapter, we'll talk about why setting equations to 0 is so helpful. But for now, just know that setting a linear equation to 0 is standard form. One last thing before we look at a few linear equations. How do we solve them? What even does solving an equation mean? Previously, all we did was simplify. Simplifying is when we make an expression or equation easier to read. Solving is different. Solving an equation will produce a solution for x. This is what we want, and the goal of this chapter. We are going to solve for x. Let's look at our definition equation. Ax plus b equals 0. In order to solve an equation, we must do something to both sides. If we want to keep our equation equal, whatever we do to one side, we must do to the other. In this definition equation, we know what a and b are, but x is a variable. So let's find out what x is. The goal in solving an equation is simply to get x by itself. So let's start by subtracting b from both sides. Ax plus b minus b equals 0 minus b. This becomes ax equals negative b. Okay, so now we have one term on the left and one on the right. We still need to get x by itself. So what we can do is divide both sides of this equation by a. Ax divided by a equals negative b divided by a. This becomes x equals negative b divided by a. Well, there we have it. We figured out what x is. For linear equations, x is equal to the negative of b divided by a. Let's look at some simple linear equations. Number 1. 7x plus 14 equals 0. Okay, now we get to see how some of these linear equations will look. We've already learned what exactly x is. But let's use the same procedure again so that we can see solving in action. First, we're going to subtract 14 from both sides. 7x equals negative 14. Now to get x by itself, we're going to divide both sides by 7, leaving us with x equals negative 2. If we were to plug negative 2 back into our original equation, it should come out to equal 0. 7 times negative 2 plus 14 equals negative 14 plus 14 equals 0. If the equation is true, we've solved it correctly. If not, we've made an error somewhere and should backtrack to find it. Number 2. 5/3 x plus 5 equals 0. Now we have a rational number for our coefficient. That's no problem. What we want to do first is multiply the entire equation by our LCD, which is 3. And this will get rid of our fraction. 3 times 5/3 x plus 5 equals 3 times 0. This becomes 5x plus 15 equals 0. Now we can continue normally. 5x equals negative 15, which becomes x equals negative 3. If we plug negative 3 into our linear equation, we should get 5/3 times negative 3 plus 5, which equals negative 5 plus 5, which equals 0. Number 3. 5/2x minus 4/3 equals 0. Now both real numbers are rational. Let's use the same method from number 2. We'll multiply the whole equation by the LCD, which is 6. We'll have 6 times 5/2x minus 4/3 equals 0, which becomes 15x minus 8 equals 0. Now we can solve for x. 15x equals 8. This gives us x equals 8/15. You'll not always get whole numbers when solving linear equations. Let's plug this number back into our linear equation and see if it's the correct solution for x. 5/2 times 8/15 minus 4/3. This equals 4/3 minus 4/3, which equals 0. As you can see, it was the right choice. Number 4. 5x minus 4 equals negative 5x. Now we have something that might confuse someone. We no longer have a single x variable. What happens now? Well, first things first, we want to put this into standard form, and that means making the whole equation equal to 0. So let's add 5x to both sides so that we can get the 0 on the right side. We'll have 5x plus 5x minus 4 equals negative 5x plus 5x. This becomes 10x minus 4 equals 0. Solving for x will give us 10x equals 4, which becomes x equals 2/5. Let's plug 2/5 into our equation and see if it works. This time, since we have a variable on both sides of our equation, let's keep the equation as a whole instead of working with just one side. 5 times 2/5 minus 4 equals negative 5 times 2/5. This becomes 2 minus 4 equals negative 2, which becomes negative 2 equals negative 2. Even though our original equation did not equal 0, we was able to put it into a form that did equal 0, which allowed us to find our solution for this equation. This lesson covers about half of what I want to cover. We have introduced the equation as a mathematical statement and giving a special name to one kind of equation, the linear equation. There are many types of equations that we are going to encounter, some of which we will want more coverage than others. In the next lesson, we're going to look at a few properties of the linear equation. These properties will tell us vital information about the equations we're exploring.